memory, something we need to enable the open telemetry deployment to have the permissions on the cluster level in order
Correct,
to
correct. Yeah.
so that is
Okay, you
becoming
meant the CPU and memory
memory.
of each of the replicas of the pods, right?
That's right. For that,
Okay,
can we
okay,
use
okay.
Prometheus? Is what my ask is.
Yes, yes, yeah, yeah. I thought the HTTP count,
That is
HTTPS
anyway done,
request
sir.
count.
That is done
Okay,
by
okay,
hotel collector. However, the
okay,
CPU and memory, it is
okay.
pretty
Yes,
straightforward,
yes.
done by
Correct,
Prometheus.
yes. Yeah, agree, agree. Yes. However, you will be still using Kubernetes service discovery there, right? It's not direct access, yeah, because the IP address is not reliable
Correct.
for these parts. Yeah.
So
Okay, all
you
right. Yes,
will
yes.
be allowing us to use Prometheus to get the
Correct.
CPU and memory
Yes,
correct. Okay.
yes.
Thank you, sir.
But I have some doubt. I'll go last ones, these questions regarding the
Okay.
assignment.
Sure, Gautam. Yeah, maybe we'll like whoever has any queries on the assignment, given last class we kind of detailed it, I mean discussed in detail about the assignment and all. I would like to cover the syllabus necessary for the end sum examination. So let me cover this till the like 7:50 or so, and then after that we can, I mean, whoever has questions can probably stay back and we can discuss those. Is that fine?
Yeah, yeah, that will help, sir.
Okay.
Yes,
Okay.
yes.
Yeah. Thank you. Okay. So today's is contact session 15. Yeah, I've started the recording. Let me quickly check. Yeah. And the agenda for today's session is mostly on the IAC or infrastructure as code tool, and we'll discuss about briefly about what is IAC, the history of it, and then discuss about Terraform in more detail. And Terraform versus Ansible versus Helm is something I'll try to cover. Serverless IAC as well, we'll briefly discuss and move on to the security in DevOps, wherein we talk about DevSecOps, DevOpsSec, and SecDevOps, right? The difference between these and more details around them. Okay, so this is the agenda. So let's jump on to what is IAC. So as part of exploring IAC tools, specifically Terraform, you may have to download the Terraform. So I'll first share this link so that while the lecture is going on, you can probably download this on the side, right, and keep it handy. So please try to download based on your OS the respective zip file here. For Windows, for example, mine like the 64-bit laptop, I have downloaded this zip file. And once we download that zip file, all we need to do is just unzip this. Right? So I'll quickly show this. We just have to download the zip file and then unzip this. And wherever it is, I mean, wherever you want the Terraform to be. And lastly, we have to add this to the environment variables. So a terraform.exe file will be present once you unzip this. And in the environment variables in the path, we have to add this to the path. So I think uh, Terraform here. So this is the location where I have unzipped the folder, but you can unzip it anywhere, but it should be there in the environment variables. So in my case, it is here. So once you unzip, you'll just have this executable. After which, once we come back to VS Code, right, we should be able to check the version of Terraform using Terraform-v. It should print the latest, right? The latest version is 1.15. So please try to set up this in parallel. Right? I have shared the link in chat, so you can please download this and keep it handy. Is that fine? Is this clear? Like how to download this and quickly set up this? Please confirm.
Yes, sir. Yes.
Okay. All right.
We have download it now. When
Yeah.
just
Yes. 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 And one more is please open your AWS account. So if you want to do in parallel with what I'm trying to do here, try to keep your AWS account active by logging in and so on, so that you can follow along when we discuss. So these two, please have them handy. AWS as well as Terraform.
So the AWS lab would be the cluster lab, which is kind of I've opened from my DevOps console lab, DevOps,
Correct.
and
Yes.
there I connected from the AWS. And the Terraform, the link which you gave would be installed locally on my computer.
Correct. Yes. Yes, they went there. So that
I
way.
installed it and the zip
Mhm.
unzip also I did, and after that
Okay.
it's not executable, I think.
Yeah. After you unzip, you should see something like this. This particular two files, license and Terraform. So this path, you have to add it to your path in the environment variables, after which you will be able to execute Terraform related commands.
It
Okay.
worked for me, sir.
Okay. Thank you very much for confirming. Yeah, just try this out, Gautam. Like once you have this unzipped, just copy that path and add it to the environment variables path. Is that fine?
It's not working. Let me try again.
Okay. Okay, so far, as part of the whole DevOps lifecycle, we have explored mostly all the stages of DevOps, including continuous observability and continuous monitoring as well in the last couple of classes, right? So this particular part wherein we are trying to look at how do we set up the infrastructure that is needed for our applications, right? So just to recap the quick story or the learnings we had so far, we learned about how to build an application, right? Python based application we had seen, and Java based application as well we have seen. We tried to use build tools. I mean, firstly, we tried to have the application code in version control system, and that is where we discussed about distributed version control system and continue centralized version control system. And in distributed, we specifically discussed about Git in more detail. After which, once we have the code either in Java or Python in one of the version control systems, the next phase was to build that or package that using build tools like Maven and Gradle for Java. And Python has some built-in build tools as well, which we can use. And in Python case, it will be a wheel file that we generally generate. And sometimes people also generate the tar .gz files, tar files. And in case of Java, it is jar typically that we try to generate, right? So once you have this artifact, we were checking those artifacts into Artifactory location. And secondly, we talked about how to containerize the application using Docker. We containerize those apps, and once there were many containers created, we discussed it is difficult to orchestrate all of them, and that is where we wanted some orchestration tool like Kubernetes that takes care of all these containers for us, right? It helps us manage and so on. And it is more declarative in nature, that all the configuration, the YAMLs or the manifests that we write is declarative for us to control what happens for our application. Right, but for all of these to happen, and lastly we discussed about continuous monitoring and observability, the need for it. It is like we have to try to keep watching out for the applications that we have deployed, and try to identify issues and fix them before our customers get to see them, to give them that seamless experience, right? High availability and zero downtime, and so on. So those were all the things or phases we had discussed till like 14 lectures, right? So now the missing piece here is uh, all the infrastructure that is needed for our applications to run. For example, Kubernetes cluster itself or some AWS EKS cluster. who would create that, and someone has to do that before we can get to deploy our application, right? So all the necessary infra has to be in place. So far we were assuming that is in place because either we were using our laptop's Kubernetes cluster, or we were using like AWS EKS or so, right, as part of your assignments as well. And it was always like kind of manually created by us, right, by doing a few UI actions, and then we got the necessary infrastructure setup. But in production, when we want to, as DevOps engineer, when we want to deal with the infrastructure, um, having these manual routes, or having some UI to set up these environments is not recommended, because it's not scalable, it's not repeatable, and it is not human error free, right? Like for example, as part of your application, let's say you need at least two servers, one database, and one security vault or so that maintains all the secrets. Just three, four things as well. If you think about, for each customer, this same set of infrastructure has to be set up for deploying your applications, which means let's say you have like 20 to 30 customers. The problem is scaling up, right? As the more uh, number of customers increase, the environments increase, and it becomes very difficult to manage all of these, right? Especially the infra for all of these. And so people have thought about this problem and thought like, just the way we were writing code for the application, right? We were writing the application code, which is either in Java or Python and so on. Similarly, for the Kubernetes as well, we were writing the configuration as code, right? CAC, which is where these manifests or YAML files have come in. Can't we write even the infrastructure as code, right? So that is how IAC tool has started. And it is basically from code, it is declarative. I mean, there are like two types of IAC tools, declarative and imperative. We'll talk about them, but I'm hoping the need for writing this as code is clear, because that way it is repeatable. Like the same code you just execute 100 times for 100 customers, right? You don't have to manually do any of these steps to provision an environment, right? And secondly, it is human error free, because uh, all the steps are predefined and declared and reviewed, and then checked into version control system. So that way it is I mean, when we were to manually provision them, we may miss out one or two steps, but if it is automated using this script, then it is repeatable and reliable, right? And thirdly, it is scalable as well, because more the customers, you just have to check out this particular IAC code and then keep executing them in n number of servers, right? So it's scalable, repeatable, and human error free, right? So those are some of the reasons to have the whole infrastructure set up as code, right? Infrastructure as code tools. So some of the popular IAC tools are like Terraform, AWS, CloudFormation, Ansible, Chef, etc. So Ansible and Chef are more of configuration as code tools, wherein you write the configuration, desired configuration, or some of the installations of certain packages that you want to do on a server. You can use these, but Terraform is uh, vendor agnostic, they say, or platform agnostic, which means it can work with AWS cloud, it can work with Google cloud, it can work with uh, Oracle cloud, it can work with even uh, Azure, right? So that way it doesn't have any script that is specific to anything, whereas AWS cloud formation IAC tool is specific to AWS, right? So that way Terraform has gained more popularity. So maybe let's briefly discuss the history. Right, in early 2000s, the concept of configuration management tool has begun, right, with the rise of virtualization. Like when you have more VMs, more containers, and so on, that is where people started to come up with this thought of having some tool to automate the configuration or the setup that you do in each environment. So in 2005, we had Puppet, then we had Chef in 2009. And Ansible was later released in 2012. So all of these tools were primarily focusing on management of system configuration, as well as Chef offered Ruby DSL, which is domain specific language. Right. So these were all developed wherein they were also called imperative IAC tools, which means you have to write more code explicitly for something to happen. Whereas declarative code, on the other hand, is more like you just tell what you want and the tool takes care of that, the underlying things, right? Whereas so in general programming languages as well, we have imperative and declarative languages. I think we discussed this earlier as well. So imperative are either, I mean, if you look at C, Java, Python, etc., each and every line you explicitly write for the tool to know what to do. Whereas in declarative ones, for example, HTML or SQL, there you just say you want a button and you get a button on the screen, right? You don't really write the rendering logic for the button. Right? And for SQL as well, you just give a select query to fetch the data, and the actual data fetching logic, the underlying C procedures, are fired by the database management system to get I mean, to read all the relevant files on the hard disk and then get you the data. Right. So that's the difference between imperative and declarative, and we are moving towards more of declarative tools, and one of them, which is open source and very popular because of its platform agnosticness, is Terraform, right, which was developed by HashiCorp in 2014. And so this kind of became a standard, more or less, Terraform, right? So yeah, declarative versus imperative. In declarative, you just focus on the desired state. You just declare what you want at the end, how it should look like, and Terraform and AWS CloudFormation come under this. Whereas imperative, you explicitly describe each step of how to achieve something, and Ansible and Chef come under this. Right. Even in this AWS CloudFormation, we will not focus on because it's specific to AWS, whereas Terraform is cloud agnostic. Right. So that's the reason of picking Terraform over others. Right. I'm hoping the need for IAC tool and the types of IAC is clear. If you have any questions, please feel free to ask.
Yeah, good, sir.
So just to look at a sample snippet of how a chef recipe looks like, it's written in Ruby, and this is how you would, for example, declarative versus imperative. We are just comparing, and the end goal is to provision an Nginx server on AWS EC2 instance. So here you would say execute this, basically API apt get update, right? We generally update all the packages using apt and then install Nginx. So here you literally tell like step by step what needs to be done. Whereas here you just declare like I want AWS instance, and in that I want Nginx, right? You're just more of declaring that you need so and so AMI ID. This is Amazon Machine Image ID. Instance type is T2 micro, the family of or shape of instance that you want to have. And you're, as you can see here, the code is more of declaring, whereas here it's more of giving step-by-step instruction of what to do, right? So that's brief difference between these two. So in Terraform, the scripts are written with an extension of .tf, tf for Terraform. And the language that we see here, the declarative language that you see on the right side, is called HashiCorp's configuration language, or HCL in short. Right. So HashiCorp is the company that we saw here as well. In 2014, they have developed Terraform and made it open source. So they came up with the new configuration language, which is more declarative in nature, and this is called HashiCorp configuration language. Right. So what is the new infra trend? Earlier, servers were getting created and destructed, and that took a lot of time, right? And infrastructure was provided by system admins, and it was completely like manual. And application servers were long living, and they were downtimes whenever patching had to happen, right? Whereas now the new trend is these servers creation and destruction happens in seconds, right? Because a container is the one that we usually use to run a particular application. It's microservice architecture, and it is all those pieces of that application as well, the microservices, they are bound to be, I mean, the pods concept that we discussed, which is they keep dying and they'll keep getting recreated, which means creation and destructions should happen within seconds. Whereas here, the virtual machine used to take a lot of time for boot up and shut down and so on, right? So that was the difference in trend. And secondly, the infrastructure is provisioned via code. It's no longer manual or maintained by any system admin. DevOps engineer itself takes care of even the infrastructure provisioning, and it's again part of code and is automated. Right? And app servers there earlier were very long lived. Right? Like once you set up a server, you hardly take it down. Whereas here, the application servers, which are more or less like containers, are very short lived. And the second aspect is they are immutable, right? So whenever a container, a pod gets killed, a new pod is created, which is a completely new instance. It is not basically restarting the older one, right? You just get a new one, and that is how the IP address as well was keeps on changing. Whereas earlier it was mutable, like the same server we used to patch it to upgrade from one version to another version. Whereas here, when you upgrade from one version of application to another version, a new set of infra or new set of pods are created and older ones are terminated, right? Well, that's how we had the deployment, which basically helps us do this rollover strategy, so that at one point in time we see that max search, max unavailable, and so on we configure that. Slowly all the older pods get killed and newer pods with the newer version are created, right? So there's the new infra trend. Any questions, anyone on this, or is it fine so far?
Good so far, sir.
Okay. All right. So coming to key IAC principles, one principle called idempotency. I think you would have learned in schooling days as well about this, right? Wherein idempotent function like I of x is x, which means as long as if you keep giving the same input, you always keep getting the same output, right? So identity function or idempotent function is even if you run the same code multiple times, you should get back the same result. Right? And this is specifically most important concept in infrastructure management, because let's say you have a logic to create a server called S1, right? Um, and first time when you run it, the server S1 doesn't exist in real world, so it will get created. But the second time you run, it should not again attempt to create another server, right? Generally, when we write programming code, even SQL for that matter, if you have a create table statement, second time you run it, it will fail saying table already exists, right? It shouldn't fail in this case. It should always yield the same end result, which we expect, that is server one being present, right? Or being created. So second time we run, it should probably skip this whole server creation. Right? And in programming, this generally doesn't happen. For example, every time you run the code, it always starts from the top of the file, right? And it executes each line again and again, right? Every time you execute. But this is different. The IAC configuration is a bit different in this perspective, that it should be aware of what is the actual state and what is the desired state, right? This is similar to, I think in Kubernetes, we discussed this. All the YAML files that we write are the desired state that we are declaring, and Kubernetes sees our desired state. We say we want 3 replicas, but in real world, in the Kubernetes cluster, there may be only 1 replica. That 1 replica information is actual state. So it compares the desired, which is 3, versus actual, which is 1, and then tries to adjust the actual state to match the desired state, right? So that way it will spin up 2 more pods or deployment, whatever, and equate the number of replicas, right? So it always works for matching the actual state with the desired state. Same thing happens here as well. We declare our desired state in these Terraform files, .tf files, and then Terraform looks at what is the actual state and then compares these two and always tries to sync them or match them. Right, so that is about idempotency. I'm hoping this is clear. Then comes the version control integration. So how the application source code exists in version control system like Git. Same thing we can do for this infrastructure as code as well, so that we can back up that infra setup configuration, track it, revert it as needed, and so on, right? All the features that we get from utilizing version control are available even for infrastructure now. Earlier it was only for application code, now it is even for infrastructure. So whenever we provision a particular cloud resource, there are typically these three ways of procuring that particular resource, right? So the first one is using the graphical user interface or GUI, right? And it is manual because there is a UI and some person has to take manual actions, UI actions on top of it. So just to simulate this flow, I'll quickly do a demo of this, right? So for manual one, uh, let's try to create an EC2 instance, right? So I'll go to EC2 here. Right? And currently the instances wise it is 0. So I'll click on launch instance. And I have to give some name here, right, for the server. So I'll try to give it as GUI VM, right, indicating that it is being created using GUI, right, just to, because later we will create the same EC2 instance or other buckets and other things. These are the infrastructure or resources, right, so that we are trying to create. So here, firstly, I'm showing the manual route, the GUI route, so that it's clear of what all we typically do. And the same thing then we'll do it from using Terraform. Right, so that is where we want this local Terraform setup so that we can interact with this AWS environment that was given to you from the laptop, and we'll have the Terraform create this later. Right. So first, quickly, let's follow these steps. So first thing is we need to give some name here. Right. This name is this name actually goes under tags with the key value. It's a key value pair. Key is name and value is this. Right, for that instance. And here I'm selecting Ubuntu. We can select any of the images here, right? And so Amazon machine image is in short called AMI. And here it is picking up for Ubuntu. The latest is 26.04, right? You can check the same by going to Ubuntu downloads as well. Right, here also you see that the latest version of Ubuntu is 26.04 and AWS is also providing the same, right? And it is free tier eligible. So that way I'm choosing this. And yeah, there's the AMI ID, right? There's the ID of that particular image. And instance type is basically a combination of how much of CPU, how much of RAM that you want to have for your instance, right? And there's called shape sometimes, or some places it's also called family. For example, if you see family is T2 here, and then nano means you will get one virtual CPU and 0.5 GB of RAM. If you keep increasing this, for example, you go to T2 micro, which is free tier eligible. There you get one vCPU and 1 GB of RAM. I mean, for our example, we'll stick to this free tier again, T2.micro, but I'll just show you, like, if T2.medium, if we were to choose, we'll get 2 virtual CPUs and 4 GB of memory. Right, so that way it is and similarly the charge and everything is mentioned here. So you pick one of these, like based on the application requirements, you pick one of these instance types or family. We are sticking with T2.micro. And the next thing is, once the VM is created, once the EC2 instance, which is nothing but a virtual machine, is created, how do you connect to that, right? So for that, we will be using SSH. And to do SSH, we need a particular key value pair, which is public private key pair, right? So we can either generate a new one or select if we already had one. I'll try to create new one because I don't think we have anything here. Okay, let's create a new key value pair. Right, so for Windows, we generally use PPK extension, which is public private key, so that we can use PuTTY, tool called PuTTY. I think I mentioned this earlier, this tool, and you can try to connect to this virtual machine or, yeah. right? For Linux and I think Mac, you can use this PEM file, which you can connect using OpenSSH, right? So these are like two tools. I'm sticking to PPK for now. So I'm hoping this is clear. And algorithms wise, for encryption, you can use RSA or other types of algorithms as well. I think EDT is popular now with it has like more characters, 255 characters or so, and so on, right? So that way we can choose any of these. We have to give a name here. So I'll just call it KP for key pair and AWS hyphen key pair or so, right? Something like this. So it will get downloaded to my laptop, and using this, we will try to then log in into that system once virtual machine once it is created. Right. So this is about key value pair and network settings. There will be a virtual private cloud that will be assigned. There won't be any subnet assigned, but a VPC will be created. So we will leave all the defaults as is in the interest of time. So let's just click on launch instance, and number of instances wise, we are selected only one. And so we'll have one VM soon being created here. So sorry, it's running state. The name of this is SSD GUI. SSD is my just name. For global uniqueness, I just gave my prefix name so that you all also can follow and create these instances. Right? And so this is the instance ID and it is currently running. And how do you connect to this? Right? So that is where we have options. So I can select this and I can click on connect. Right, and tags one I was mentioning. So let me show this tags first. If I go to tags here, that is where the name that we had given earlier will show up here, right? So the name that we give to the virtual machine is nothing but a tag from Amazon point of view, with the key being name and value being SSD GUI VM. So similarly, we can add more tags as well. Like we can say tier, front end. I think those we saw like in Kubernetes under the metadata, right? So those, all the labels that we were adding there, we could do the same here with tags. Going back to this, and if I were to click on connect, there are various ways to connect to this. Either we can use EC2 instance connect, which will allow us to connect from browser itself. So this way, if I click on connect, it will open up a new browser where from browser we are trying to log in into this virtual machine. Right. So this is one route. The other one is using SSH client like PuTTY, which we can use to connect from our laptop. Right? So these are various ways to connect to this, and here I am. So if I were to do like we do yeah, so in the Ubuntu VM that we created, let me type the host name. And so this is the full host name. It is created in AP South 1 region of AWS, and it's a compute instance that got created. And here is the full IP address of it and so on. Right? So there's the detail. I mean, this much is enough. Now you see that EC2 has been created, right? So the same thing if we want to create, so this was the first route that we discussed, right? Which is GUI based. Hoping this is clear. Similarly, if you were to do partial, like do better than this, because as you have seen, everything is manual. Like DevOps engineer has to open various UI screens offered by that cloud service provider like AWS, Azure, so on, and perform all these actions. It is manual, so it is not repeatable, because next time when I'm asked to do, maybe I may miss out, maybe setting some of these flags or tags correctly, right? It's not reliable, right? Like it's human error prone. So that way it's not repeatable and scalable. Second way of creating instances is CLI or API route. So AWS provides something called AWS SDK, and it has this CLI that we can download. Right, so you can follow along on this link from AWS, and you will basically install AWS CLI here for Windows. So so it has a Microsoft installer MSI file. So that way you just download this and the installer, you run the installer and you have the AWS setup. So this is just taking one level further, wherein instead of going through the UI screens, you can use AWS command line interface commands to create these resources and manage them. Right? So this is just taking one level up. So let me quickly install this. Is the second route, and third route, which is fully automated and it has a full lifecycle management and it's fully repeatable, trackable. You can have the code in version control system and so on, is the IAC route, right, which we are discussing. So infrastructure as code is the new norm now. Right? And that way you'll have consistent environments because the same piece of code will be used, be it customer A versus customer B. The same set of configuration and same set of flags, everything will be set exactly as per the code, and it is repeatable and scalable as well as consistent. Right? It will eliminate something called configuration drift. Right? Configuration drift generally comes when you try to do this manually and there is change between one environment to another because of the uh, person doing it, and they may miss out a few things whenever they're provisioning one environment versus other. Okay, so this is about this. Any questions or comments, anyone on this, please let me
No, sir.
know. Right. So while this goes on, like it will basically give us ability to call like AWS, configure this, AWS, create this, AWS create that, and so on. Right. It's specific to AWS. It's command line route of interacting with the same cloud of AWS, and you can create instances and other things like the same VM and others. Right. So you can maybe explore this offline as well. And the one that we'll focus more time on is the IAC. So let's discuss this. So as a IAC practitioner or a DevOps engineer, the first thing is we write the infrastructure as code using .tf files, this Terraform or any other tool. And then we do something called plan, and then we do something called apply, right? So plan is basically like a dry run. So it will just run our code in dry mode, right? Dry run is generally like it doesn't actually create anything in the cloud service provider, right? In any of the clouds, it will just show you what it is planning to do, right? Like for example, you gave create 2 servers, 1 database, so on. It will say I'm planning to create 2 servers and 1 DB, so that you can quickly review before applying this. And apply is the one that actually applies them onto the cloud, the clouds that are configured, and it will actually execute and create those resources. So they are giving this plan and apply mode just to review these before doing something on the real world, right? And then we have like all these cloud environments, AWS, Azure, GCP, etc. Anywhere you can use this Terraform script and it will interact with all of these, and the infra is created, be it servers, databases, and so on. Right, so we will write the IAC code. It will reside in version control system. Then we'll have a CI pipeline that will check out this version, this particular IAC code from version control system, and it will quickly do some things like linting, which is just to see if the code that we write is the configuration we write in TF files is following best practices or not. And then as part of CD pipeline is where it will get deployed, right? Actual changes to the cloud environments will happen as part of the CD pipeline, and you can then later monitor and audit. So yeah, Terraform is open source IAC tool by HashiCorp, I think, and language wise, it will be using HashiCorp configuration language or HCL. These are written in a file with the extension as .tf, to indicate Terraform script. So they are used for building, modifying, versioning IAC safely and efficiently, right? So that is the one-line summary of what is Terraform. It's a tool for building, modifying, or versioning infrastructure safely and efficiently, right? So that's the summary. I think we discussed all these points, so I'm going further faster. And Terraform is cloud agnostic. If you were to use AWS Cloud Formation, it is specific to AWS. From Azure, you have Azure Resource Manager. From Google Cloud, you have Google Deployment Manager, and so on. These are also IAC tools. They are called Cloud Native IAC tool, which means they are specific to each cloud, right? Whereas Terraform has ability to interact with all of these. And so that way it is cloud agnostic.
Yeah, even better.
Pardon, Devinder? Sorry.
No, I'm saying, I mean, yeah, that's even better to manage all three.
Correct, yes. And it also supports something called multi-cloud IAC, which means you can have a database, let's say, I mean, maybe Oracle Cloud is better for having a data relational DB. You can have it on Oracle Cloud. And then let's say for servers, you can maybe have it on Google Cloud, and you can have a object store maybe on AWS and so on, right? So it will Terraform actually supports that multi-cloud thing, which is actually becoming more and more the recent practice or the norm, wherein people realize like actually we are kind of going back to how it was in olden days. So just to talk about this whole multi-cloud thing, I actually have I mean, we have dedicated slides which we discuss next to showcase how to set up this. But general practice wise, if some of you, I'm not sure, like if you recall, like from the long uh, back when we used to purchase a computer, right? Like good olden days, we used to do something called we wouldn't purchase, for example, the monitor, the CPU, the keyboard, mouse, all of them from the same company. We used to procure, I mean,
Assemble
do
them.
something called assembling. Yeah, that's the right
Right.
words. We used to assemble all of them, and we used to get like maybe Logitech mouse and monitor from LG, or I mean, and then uh, yeah, CPU from HP or whatever, and we used to assemble all of them, like maybe keyboard from Dell and so on. Right, so we used to do that, and slowly the things have changed, wherein with laptop you are kind of given both keyboard and monitor from the same company, like HP or whatever, right? And the same happened even in the AWS built, wherein earlier people on when they had the applications on premise, they had their choice, like they could have got servers from Sun Microsystem, Sun Systems, right? The huge servers, maybe, or database from Oracle, and maybe the uh, virtualization technology from IBM and so on, right? They had like choices where they could assemble all of them in their on their premises. And when they moved to cloud from 2006 is when AWS launched web services for the first time, and later on all the other Google and others also had offered. So since then, what has happened is people were forced to use the same tech stack that is provided as services by that particular company, right? For example, AWS will ask you to, if you want a database and relational, it is RDS from AWS that you have to use. If you want object storage, it is S3 from AWS that you have to use. If you wanted some virtual machine, it is EC2 and so on, right? So they were giving, like, they were kind of doing vendor locking, it is called, or wherein they were asking all of your tech stack to be on AWS, right? And same is the case with other clouds as well. Whenever you were switching from AWS to GCP, for example, they used to help you migrate all of these with equivalent services from Google, right? So there was no mix that they were encouraging earlier, but now in the recent times, you would have seen in the I/O events that most of these companies have, the big tech companies. You see that they bring in like CEO of other companies into their IO event, and they say now we are supporting, like we are collaborating and supporting like multi-cloud environments, right? Which means you can have Again, we are going back to those days wherein we are doing assembly. Because people realize, I mean, the cloud service providers realized instead of competing on all aspects or all services with others, it's better we try to collaborate so that customer we offer best of everything that is available, right? And they have the choice to pick, let's say, DB from one cloud and server from another cloud and so on. So Terraform actually helps in that aspect as well because it has support for all these three, and the language that you write, HCL, the HashiCorp configuration language, is cloud agnostic. Like be it Azure or GCP or AWS, you still write it in same, I mean, using the same language and format. Okay, so coming,
Sir,
yes,
quick
yes.
question there. Like, though Terraform is cloud agnostic, the terminologies would change, right? Like, for example, we call it EC2 in AWS, but on GCP we call it as Compute Engine. So, in that case,
Yes.
how do we manage that?
Um, no, so I think the names are something that we cannot really change because those are already existing and provided by various cloud service providers, right? So what Terraform is actually providing is, when we say it is cloud agnostic, it's more about the same Terraform script. From the same script, you can actually create one EC2 instance from AWS and object store from Google and some maybe uh, yeah, some security role from Azure or so, right? So it's giving you capability to interact with all the three cloud service providers using the same script and language, which is HashiCorp configuration language. Whereas if you were to use any of the cloud native ones like AWS Cloud Formation, it is a native tool for AWS to interact with AWS tech stack itself, right? So these are like not cross operational, whereas here it is giving that ability to interact with all of these using a language that is common. Like that way, all the configuration, you just need to know one way of writing it, and that way is compatible with all. Whereas here they have their own versions. For example, I think AWS has something called SAM, uh, which is I think application management. There is from AWS. So that language or format in which you write the configuration is different from Azure, right? And as the cloud service provider changes, the IAC tool changes, the format in which you write this configuration changes. So you have to like learn many things then, right? And rather than that, it's like Terraform is trying to unify and have it in a single language that you declare for all. And so that's the one that is changing. Think of it like the client side is common now. Earlier, it used each server has used to have its own client language. Now it's like common. I mean, does that make sense?
Yeah.
Yeah, sir, one question.
Yes.
Here we are saying that as in on the earlier slide,
Yeah.
initially AWS or Google, those were competing with each other across entire tech stack.
Correct. Yes.
Now, from customer standpoint, if you see,
Mm.
if I have like everything will run in single data center, right? So if I have a server and database sitting in same data center, probably at a very close proximity, I'll be getting better performance, right? Now,
Yeah,
if
that is
my
correct. Yes.
compute machine is in Amazon while my database is in, let's say, GCP,
Yeah.
that way those data centers are going to be away from each other and they are going to talk like it would be network
Yeah.
communication at longer length. So
Yeah.
from
That's
performance
a good
standpoint,
point. Yeah. Yeah. So that is assuming they are very far apart, but that's where these IO events, if you were like following, they say they are now supporting coexistence of these infrastructure, and they are like making it like a hybrid cloud, right? So that way they are bringing those two together, whichever two things that you were saying, like they may be apart, right, far apart, are being brought together, right? So basically the data centers wherever they have, they're trying to bring all the things closer to each other from both the cloud service providers, right? So that when you
right?
choose the tech stack, they are
Hmm.
very closer to each other. And so
Right, but those are
proximity
already
is
established, right? Data centers are already established. Those are
correct.
already there. So probably bringing them closer may not be possible from physical standpoint. Probably the connectivity between them can be improved, as in
Yeah.
the
So
bandwidth, network connectivity, faster lines. better mechanism to connect those data centers. That could be a technical possibility. But
Correct,
even then,
correct.
see,
Like for
why
example,
should they
it
lose the
mm,
business that way?
yeah. So I'll tell you like yeah. So one aspect is the performance that you have rightly called out. But customers don't just see about performance; they also see about the cost, right? And they also see about the the, for example, the tech expertise that they have, their infra management team has, right? And let's say they are used to certain types of uh, tech stack, right? That is what they want to replicate even when they are on cloud. Like when they were on premise, maybe they were always using Oracle relational database that they want to still continue to use. Now, in these, I mean, cloud service providers, they were actually forcing them to use their own tech stack itself. Now they are giving that choice. That's one. But more importantly, I think it's cost that is given more priority over the performance. And performance is definitely there, and that is where these uh, multi-cloud support that they are providing. Like for example, they are creating new data centers. Like Microsoft and Oracle have recently done that in Bangalore, I think, wherein they started a collaborative data center, right? Like they are actually doing that so that proximity reduces. And even in their existing regions, for example, within India, if AWS has it in Mumbai and maybe Microsoft has it in Hyderabad, they are not very far away, right? They were as bad as, for example, AWS itself, wherein you had DB in one place versus the server in other place or other region of AWS, right? So it was not necessarily the case that I mean, network IO is definitely a concern, but it was even within AWS tech stack. It's not guaranteed that you always get all the resources in the same availability zone or
Agreed,
same region. So
agreed. But
yeah, that those are the trade-offs. Yeah,
if it is availability zone within AWS, then probably the connectivity between them will be much better than,
correct.
let's
Yeah,
say, AWS and Azure, right? If you
yes,
go
yes,
with that particular analogy too. So physically they might be at the same distance, but from connectivity standpoint, the speed with which data transfer would happen would be
correct.
fairly
Yes.
high, right?
Yes, yes, that is there. It's just that, like I said, cost. For example, like let's say if you wanted to procure some relational database for your application, and you see that what is the best in the world. I mean, among all the cloud service providers, you may choose one of them, right? And similarly, cost-wise also you will compare. So when you want to make those choices, network IO alone is not the driving factor, is what I'm trying to say.
No, no, agreed,
Network IO is
agreed.
definitely there.
Mhm.
That's a valid so that's the trade-off which we want to do, right? Like anyways they will test all of this in staging environment, and then only once everything is fine, like it meets all their SLA, they will take it to production. So but now they have more choices, and even the cloud service providers were not supporting them. For example, the firewall of AWS used to block any incoming traffic from other cloud service provider and so on. Now they are more collaborative and open, right? So that's what they are declaring in all of their annual events. And same thing now, I mean, customer has more choices to pick the
Pick and
respective
choose
tech stack.
between. Mhm.
Yeah,
Right.
yeah,
If you see, everyone has almost entire tech stack available, and same services are there. As in,
correct.
service A in this particular provider, service B in other. So you
Yeah,
can translate between them. So having one entire tech stack is still possible, right? Whatever code you
correct.
have.
Yes, yes,
So if you want to move from AWS to GCP, that wouldn't be too difficult that way.
correct. Yes, agree.
But having a hybrid stuff is, and again, if you see, typically organizations have huge amount of data, trillions
Correct.
and
Yeah,
whatnot entries. So if you have a compute in AWS and data in GCP, if that huge amount of table data travels across network, then it's going to be horrendous, right? If you consider picking
correct.
up
Yeah,
1 lakh entries from database and getting
yeah.
them for computation part.
Yes,
So,
yes. Yeah,
like, I'm
agree
not
to
able
that.
to
Yeah,
envision. Yeah,
yeah.
I'm
The
not able to
only
envision how
yeah.
it would be performant, though it is cost effective.
Yeah, so that's the like I said, that's the trade-off. Like let's say some batch process that performs some type of analytics and ingests those into some system that customer looks at the next day, right? Like let's say there's a batch job that runs in the night time. it takes like 6 hours or so to run everything, and I mean ETL and other things, and all the analysis insights it will persist them so that next day the customer looks at them like daily basis. They have a dashboard that they look at. Now, in that batch process, earlier they were forced to have the same tech stack from AWS. Now they have the choices, so they will obviously go with something that gives them that cost benefit, right? Their performance is really not a concern because even if it takes, let's say, 8 hours instead of 6 hours, it's still okay because customer is not even expecting to watch them as soon as possible or so, right? So those are the ones. Like there are certain applications where latency is not a mission critical concern,
problem.
right? So yeah, so that those applications they can actually do this optimization further, right? Now they have a choice. Earlier they didn't have a choice. That's the major difference, right? Like now they have a choice, and Terraform in that sense is actually supporting that, right? To have them, and also from other standpoint, like for example, within organization as well. Like let's say I'll give you one more example. These mergers and acquisitions are very popular, right? Like in the software world. So let's say one company was completely using AWS cloud service provider, I mean tech stack, and then they acquired some company, right? Because they felt it was competitive. This happens everywhere in the software. So they acquired some other company, and let's say they had everything in GCP, right? So now you want to, with the same employee count or resources at hand, you wouldn't want to have expertise in both and manage them, right? Because whenever this acquisition happens, usually the company that is being bought or I mean merged, there will be headcount reduced from there and it'll merge out, right? So those cases as well. Terraform is a unified language to interact with both types of cloud service providers, right? So legacy systems are there, and there are like many use cases where you may want to have like different types of cloud and interact with them. And here it is allowing you to unify all of them into one specific configuration file, like unified language, and have it in your version control system.
Yeah. Understood. Thanks.
So the
Okay,
other
so
angle to that is like you said, the cost is also a thing, right? But
correct, yes.
when resources are across clouds, obviously there would be egress associated with it. So how is it cost effective? Uh,
Yeah, I mean, it depends on, like I said, when we have to take the specific example, then it'll be very clear. But I mean, so it's like uh, this batch process, like I said, 6 hours. Let's say they were paying like maybe $1.2 or so per hour to AWS. And now instead it is changed to 8 hours. I mean, it's slow in the other environment, but they are giving you at only $0.2 per hour. Then effectively, like into 6 hours, if you do the math, effectively you see that even if with egress, additional cost, whatever you have to do to open networking between these two clouds, overall effectively it is still beneficial because this happens every day for you. Like this batch process runs every day. So over the year and long term, moving from one cloud to another for specific tech stack is beneficial to you, right? Even though there are like some overhead involved in, be it performance or be it the infra needed to make them talk to each other.
got it.
Okay, so I think most of you have now installed this Terraform itself, and you can do, I mean, some of you have pasted the output as well in chat. So Terraform-V to get the version of Terraform, right? And hoping everyone has that 1.15.2, which is latest, right? So there are only two concepts in Terraform that we have to learn, right? First thing is, um, so how is it that magically, I mean, we are saying it's cloud agnostic and Terraform is like cloud agnostic. It will be able to talk to any cloud service provider and all. Whereas we have seen that each AWS and others have their own SDK, right? They have their own software development kit and their own way of talking to the cloud. And how is it that Terraform tries to neutralize all of this, right? So it has a concept called provider. Think of it like a plugin. For example, in Chrome browser, you have something called extensions, right? So you can have an extension to read Google Doc. You can have an extension to read Microsoft Word, right? Both are essentially for reading documents. One is from Google and the other one is from Microsoft. But you can just have two extensions which are specialized in reading each of these, and both the extensions you can install in your Chrome, right? So Chrome is the same browser. The similar analogy you can have with Terraform, wherein you will get those in the form of something called provider. So what HashiCorp has done, right, is they have tried to write the client specific or cloud specific logic and abstract using their interfaces or their API, right? So the specific one that each of to interact with each of them, let me open Terraform here, right, are called providers, right? So provider use, if I click on this, these are all the list of providers. I think there is a library here which we can get. Yeah, Terraform registry is the one where you have all the providers. So you have a provider for AWS, for Azure, for GCP, and so on, right? So that is how um, Terraform makes it, I mean, language wise, it's the same, but in that language, it will use the specific provider that you declare and you can make use of. And these providers are specialized agents, think of them. They know how to talk to AWS, right? So this provider knows how to talk to AWS to get your work done. This provider knows how to talk to Azure and get your work done. And so something like this. This is the concept of providers. So so this is our demo folder. We'll try to create one more folder for this. I'll call it IAC demo. Similar to last time, we will try to have all the commands list as well in this IAC demo. Let me create a new file called commands.txt. So all the
So
things
we
I
should
run with.
add,
Yes.
sorry to cut you. Like I had a quick
Okay.
question. Should we add the folder part to the environment variable, or should we add that terraform.exe file part to
Yeah,
the
the folder
path?
one. Yeah,
Okay.
folder.
Because I added the folder and it was throwing me error. It was not able to identify. So
No, folder should be enough.
okay. To the path variable, right?
To the path variable. Like if you see
Yeah.
here, I have it till C users HP Terraform.
Terraform. All
And
right.
Terraform is actually a folder for me,
Got
in
it.
which I have again Terraform, this one.
All right.
Yeah, I have copied it in documents and I pasted that path till documents and it kind of started giving me version when I typed that command.
Okay, so I think, I mean, so is it working for you, Devinder? That's what you meant, or?
I mean, I checked in command prompt to type that version command, which was pasted by somebody in the chat.
Okay,
I see in the chat somebody pasted type this command, and I think it
okay,
is Ved Pathak who typed it.
okay,
And I use the
It's
same
giving me error.
going.
okay.
Maybe you
Yeah,
close
same
command
thing.
prompt again, you reopen it, sir, after environment variable set.
Yeah, you have to reopen this particular VS Code after you have set the environment variable. I mean, after you have added it to the path.
Yeah, I did that. But
When I run the exe, it
Okay, maybe
opens for a
I
second
think
and
Gautam,
closes.
if you can maybe share your screen, we'll quickly debug that. And that way I'm hoping for others as well, they'll be able to follow.
Yeah, I'm sharing.
so you may have to enable share screen for the
Yeah.
everybody.
Yeah, I'm not seeing that option.
Yeah, mine got fixed as well now.
Okay. Yeah, I think I have to give one-on-one basis, allow to present, right? So, okay. Okay, yeah, Gautam, you can maybe. Okay, I made you the presenter, not sure.
Okay,
That
okay,
way.
I'm sharing.
Yeah, yes.
So if I run this,
No, we should not run this.
okay,
Did
the
you add?
CX.
Yeah. No, this is not meant to be run. Like this particular
Okay.
path, download / Terraform, whatever. Did you add this to the path?
Okay, environment variables.
Correct. Yeah.
Okay, I'll do that.
Yes. Yeah. After which you have to run this from VS Code, like terminal, like how it's running, or command prompt.
Okay.
Yeah.
Yeah. Any name I have to give? Well, Terraform only, right?
Yeah.
Environment variable.
Anything. Yes.
Okay.
All right, so once we have Terraform, I have created a file called main.tf. And in case VS Code is not recognizing this, you can go to extensions and search for Terraform. Right? From HashiCorp, you should have an extension that you can try to install, right? Not this, but this one. So HashiCorp Terraform. This will help you to have syntax highlighting and auto completion. Right? So these are specifically useful when you are not too sure on the right syntax to have, or you're not sure on the full name. It will help you to auto complete these. Right? So it is always good idea to have this. Yeah.
This is what you are right now showing on your screen.
Yeah.
Is this part of VCode?
Yeah, the VS Code extensions. Yeah. So left side, I have clicked on this icon that takes you to extensions.
Is
This
it?
particular.
It's the same Visual Studio Code, right?
Correct. Yes. If you see
Yes,
this
sir.
one,
Okay.
I mean my mouse here, this part,
Yes,
right?
yes.
Extensions. Yeah.
Correct.
Okay. So that is about provider. So what I can do now is I can say provider, and the syntax for this, maybe let me go to the slide. So it is provider space the cloud provider name, and generally like AWS or I think for GCP it is Google, for Microsoft Azure it is Azure, and so on. So that name, if you wanted to, you can get it from here. For example, I go to AWS here and I say use provider, it will already give me the code for this. Right? So I just have to copy this and have it here. Right? So inside Terraform, we say these are my required providers, and I say I define a variable called AWS, where I say the source is HashiCorp / AWS, which is the provider path here. If you see this, right, HashiCorp / AWS, and the version is 6.44. Same thing we are mentioning here, so that for the specific version of provider, and we are making use of this, right? And then you can define the provider here and add any configuration options here, right? What are the configuration options? For example, the region, we can set it here, right? And region, we have to set it same as what we have in given from bits. So let me, oh god, this got set. So here, I think the region that is recommended is to have AP South 1, which is region Mumbai region. So that we can define here. That is recommended by bits as well. Right? So AP South 1, we can add as the region. Right? So AWS, and then we are setting the region. Right? So this is the provider. And what is the benefit? The multi-cloud thing that we talked about is we can add one more provider, right? For example, and then I say like something like Google. Like, how do I know that it is Google, right? So that I'll show you here. We go back to the provider list, click on GCP now, and here I say use provider, and it gives you this. Right? So here it shows that it is Google. right? Version is 7.31. So I'll quickly copy this. So in the required providers, I just have to add this part because I already had Terraform and required providers. So I just have to end this AWS and add one more like Google here, right? And then I can use this in the provider list like this. Right? For example, the region here again. I mean, we don't have GCP account provided from Bit, so I mean these two now we can't really set, but I'm just trying to showcase how it would look like. Right? So you have a provider for AWS, for Google, and so on. Right? Similarly, one more. I think you get the idea. Right? So this is how it is supporting interacting with multiple clouds. Right? For Azure, it will be like this. It's Azure RM is the name. Right? So you copy this, have it here. Sorry, not here. Here. And that way we defined all the required providers and their specific versions. And now we can make use of Azure RM as well. Right? So these are the three providers that I have declared. So usually what people do is instead of having it as main, they just call it like providers config or providers.tf so that everything, I mean, all the providers and their configuration, you have a single file. You come back to this and look at, oh, what was the version of AWS that I'm using, GCP, Azure, whatever. And you can have one more file like main.tf where you actually make use of all of these. Hoping this is clear.
These versions are, I mean, CLI version.
No, they are versions of the
AWS
provider. No, this one. The version of
provider,
the HashiCorp Azure RM provider.
Mhm.
So they also like HashiCorp team will keep releasing new features and other things, right? To support more things. So we have to use this version. This is like in Kubernetes YAML, we were using that version V1, which is version of the Kubernetes API, right? Like the Kubernetes is releasing. So same, similar to that. All right, so we have all the providers. So now how do we run our first thing on this, right? So we do something called Terraform init, right? First of all, I'll change directory to ISE demo folder. And we do something called Terraform init. Init, like how we did git init was initializing git folder. Here Terraform init will initialize, basically try to download all the providers that we mentioned in our file, right, in the Terraform files. So look at this, it is saying finding HashiCorp/Azure RM and this version, AWS and GCP. It's typically one-time activity, right? Initialization, like git init also, you don't do every time you use git, right? I mean, for a repo, you only do it once. Same thing is true here as well. So there, if you recall, it created .git when we did git init. Similarly, Gradle init created .gradle. Here it will create .terraform, right? Terraform init created .terraform. And inside this, it will have a folder called providers, and it will have one for AWS, one for Azure RM. It has downloaded. Google one, it is still going on, right? So what will, here you can see the exact executable file, which helps it to interact with AWS. Similarly here, the executable file, which will help it to interact with Azure. But from our point of view, we are just making it declarative, like how we have it here. It is consistent, right? Like you just change the source and version, but otherwise you see the format and everything, HCL language is the same, right? Like you say provider this, provider that, and so on.
Is the Terraform init reading this provider file or main file?
It will actually scan and run all the TF files. It's just that here we didn't have any code. It basically looks for all this provider configuration wherever you have. Like let's say I had this cut and paste it here, it will take that as well. It doesn't look at any file name. This providers was just a name I came up with. That's all. Just to indicate we had providers. It could have been ABC as well. Yeah.
Yeah. So what if we want to have multi-region config within the same cloud? So in that case, how do we
Yeah,
handle?
so in that case, this we can treat it like global level or default. And whenever we are creating that specific instance or resource, we override this by specifying the region again there, right? So if you
Oh,
want it to be different, yeah.
You mean like in the top where we put required providers?
Yeah, we'll actually no. So far we just talked about providers, which is
Okay.
a plugin that allows us to talk to these systems. The next concept in Terraform will actually, I mean, answer your question, right? So
All right.
let me cover this, which is called a resource, right? So from Terraform standpoint, uh, AWS EC2 or GCP's virtual machine, or I mean Azure's virtual machine, all of these are just a resource, right? From Terraform point of view, and be it database, server, object store, anything is just a server, virtual private cloud, anything that you can think of. Any infra is basically a resource in Terraform, and the way you declare this resource, right? Let's go to the syntax. If you say resource and then the provider, right? This is where the provider makes the prefix, right? And that way, AWS is virtual. For example, terminology wise, I think, correct me if I'm wrong, but as I recall, like Azure and GCP both call it virtual machine itself, right? So that way, the resource type will
Compute
be
engine.
virtual. Okay, compute engine, correct. I think then Oracle Cloud and this one, Azure, both call it virtual machine, right? From yeah. So there, the resource type is same, which is virtual machine, but the provider is different. So that way it is having that unique prefix so that it knows whether it has to talk to AWS to create that VM or, I mean, GCP or Azure or whatever. Right? So the provider that we created earlier is useful in creating a resource. So you say provider underscore the resource type underscore the resource name. This name can be any name that exists within Terraform itself, right? This name that you see here, for example, look at this. Here we are saying resource AWS and we are creating an instance, which is EC2 instance. And the name we are giving here is web server. This web server is just a name in the Terraform. What goes and sits in AWS is the tag, right? If you recall, that's the reason I showed you the tags in the UI, right? Under tags, whatever name you give, this is the name that goes and sits in AWS. So my web server is the name, not web underscore server that you see in AWS. This is a name just for within Terraform, this object, you can have this name. Right? So there are two different names, resource name in Terraform and resource name in AWS for the same resource. Hoping this is clear. And here is where that AMI ID that we looked at is needed. An instance type as well that we discussed, like t2.micro, the family is needed. Right? So we will now do this in practice anyways. And that way, when I give the name and all, so in main, I can directly say resource, AWS instance. Instead of this, I'll say, I'll keep it consistent. So there we said GUI VM. Here we will say Terraform VM. I mean, VM getting created using Terraform.
So what is the purpose of having two different names?
Purpose of having two different names. Yeah. So, so the name that we see in each of these cloud service, providers, they are giving this facility to have it as a name here that you want to see here. The reason for having this here, Terraform specific name is for uniqueness, so that let's say the name could be same in two different clouds, right? Like in one cloud, the server that you created, you call it S1. In another cloud also, you want to call it S1, right? Because they are different. Whereas here, you have to give it different, right? Because they are different objects. Does that make sense?
Yeah, agree. That
Yeah.
that kind of answers.
Yeah. So this is not the primary key. I mean, from database point of view, if you were to look at, this is not the primary key that Terraform relies on. It relies on this name, right? Which is always unique, right? Because it will say that resource already exists when you run Terraform script. If you copy paste this two times, right? In fact, if you copy paste this two times also, it should not complain because of the idempotency that we discussed, that all we are saying is we want a resource with this name. So even if you paste this 10 times, it will still do once, right? Only once it will create this particular VM, right? Just because we made it 10 times, it won't run it 10 times. Comments, we give it using hash. Now, I think there is some syntax issue. Let me fix this. Yeah, so this is the reason. Yeah, whenever we copy paste from the slide, it always happens that these codes don't match. Okay, so this is the name. Now AMI ID we need, right? So let's go to the console again, EC2. So instances wise, we already have one running, but the name of that, as we have seen, is yeah, SSD-GUI VM, right? Here, let's look at the region is AP South 1 and availability zone is B got assigned to it. We have ABC, I think, as availability regions within that, availability zones within that region. I wanted to pick, okay, the instance type is t2.micro, same as what we have done. And I
You'll have
also
to get
wanted
into
to
the,
AMI ID, yeah.
you'll have to open the, click on instance ID.
These details will have, I guess, let me see if we
Yeah,
have.
it is on details page.
Yeah, so this is the AMI ID. So I'm copying this
Okay.
and we will paste this here, right, to match this. Okay, so this is the AMI ID and instance type is t2.micro and name here, I want to give it this one, right? So just to show it is different, maybe I have to call it like within TF name or something. And within Terraform, this is the name and this is the name that you see on that UI, right? So maybe I'll have it like this. It's suggesting that to keep it sync, I'll not do this, right? So, okay. So this is what we have. Now, how does our local know which cloud to connect to, right? Like we need that configuration or it should be able to talk to
have
this
one
AWS.
question here.
Yeah, so that
Already you created one GUI so that you pick the value from here. Suppose we are going to create only for Terraform. At the time, how we come to know that ID, IAM ID,
yeah,
all those
okay.
things?
No, the reason I picked from there was just to match. But for example, when I clicked on this launch instance, here all the names were actually there. And I mean, documentation is also there. But my point is, if you click on this Ubuntu, it gave you the AMI ID here itself. This was the ID I picked, right? And there is documentation as well, like AMI, I mean, Amazon machine image list, right? So from there you can pick. Does that make sense? I mean, I just tried to pick a match with what was already existing. That's why I picked it from there. But here you have like all the image list, right? So from here you can pick the corresponding one, right? Find an AMI and you basically search for like Ubuntu based or whatever, and it will give you that AMI ID. So there is documentation like this ID. As you change, you'll see different ID here, which you can use. Right. So is that fine?
Thank you. Yeah, thank you.
All right, so how do we connect these two, right? We have our laptop where Terraform is running, but we now need to tell this local Terraform that is running here to connect to specifically this account of mine, right?
AWS
So for that,
user.
yeah, correct. So for that, there are two ways to do this. So, I mean, there are actually, I think, three ways to do this. One is we provide the, access key and the access ID. There are two things that we generally have to create. So those two, we can provide it in code in Terraform itself. But this is like you would have this in version control system, which means anyone can see those credentials and that way they'll be able to connect to your AWS account, right? So we don't want to do that within Terraform, right? So that is one. The second way is there is a extension in VS Code that we can make use of, which is AWS toolkit, right? So this will, once you have this installed, it will show up like this, right? This AWS that you see here. And here it will allow you to sign in into any particular cloud. Right? So you can configure and do the sign in here. This is the second way from VS Code if you wanted to do. But the most common thing is to set up something called an access key here. So for that, I'll go back to AWS. I'll go to what is called IAM, which is Identity and Access Management in AWS, which is used to create users, roles, groups, basically all the things related to access. And here we will create the access key, right, which we will use. I mean, user here and an access key for it, so that using that user credentials, we'll try to log in, right? And that credentials we will provide here, not in the code, but in the user home. There will be a folder called .config, .aws config that we will have to create. Let me see this. Yeah, this .config that you see, I think it's .aws. Yeah, .aws and then config. So inside this file, we will have to provide those credentials, right? So I'll not edit this here and I mean share and edit, but my point is we'll have to set these files, right, with whatever access key we see here. And so those are three ways to do this setup. I think I have all those in the slide as well. Let me pull up that slide. Okay, so I'm hoping resource and provider are clear. And flow wise, we do init, we did format, we can do plan, which will tell like what we are planning to do, and then we can do apply. And okay, so here we are trying to create an S3 bucket in slide. I will leave this as an exercise for you to try out, right? Like given VM or EC2 instance, I'm trying to create and show. Similarly, you can just copy paste this and try to create a bucket, right? In object store in AWS. So the answer is this one. From where does the Terraform read the AWS credentials? So it will look out for the current user home /.aws/credentials, right? And if you wanted to use AWS CLI to configure this, you can run AWS configure, which you can use to configure the credentials. So I'll run this and show here. If you have AWS CLI, you can run like AWS configure, right? It'll ask for two things, the
So
access
you
key
did
and
install AWS CLI, I remember. Can you run it from there? Because I too have installed it while
correct.
you were
Yeah.
doing it.
Yeah, I have it, and that's how I'm able to run it from here.
Oh, you don't need to open the terminal? Is it like connected directly?
Yes.
Yeah, because it
So
is added in path, it is able to identify
correct,
that, right?
correct. Yes, that is correct. So we have AWS access key ID. It will ask for which we have to provide, and then it will also ask for access two things, right, that we have to configure. So I mean, so once you run that, my point is you can even look at these two files, and you will see that in the credentials, it will have that entries, right? Whatever we make here, right? They will go and sit there basically, whatever you're entering here in terminal. So you can directly access that and change as well, or else we can use AWS configure. My point is we don't need AWS CLI just to set up this. We could have gone to this folder and directly added credential as well. Right? Here I'm just showing this so that yeah, I mean, just to showcase AWS CLI usage, I guess. And yeah, so here we will create a user.
Well, access key ID from where we can get. Can you
Yes,
forward
that's the one we are trying to create now here.
Okay.
So yeah, so I think we have to go to the.
I think we'll have to create a user for it.
Correct, yes. Yeah, I'm looking for that add user here.
IAM
Okay,
user.
IAM
I am
users.
users
Yeah,
tab is
yeah.
there.
Okay, yes. Yeah, that is correct. I was like looking for like roles. I was looking for you for users. Yeah, that's how I missed it. Yes, so we will use create a user. Maybe I'll just call it TF user, just to indicate this is the whole purpose of this is just to use from Terraform. I should be able to use this TF AWS user, whatever that name is. And password wise, I don't care. I mean, we can have a custom password as well. Let it auto generate, and whatever it generates, it's fine, because we hardly will use that okay, we should actually use that to showcase that it actually created something. Okay, anyways, I have the admin user, the root user here, right? My own user. So we should be able to see that instance. But even if not, let's give it some password so that we can access from here. Yeah, so in this case, so we have created the user, right? And let me download the CSV file that contains the username and password, right? The credentials for this user. And I go back to the user list, and on this user, now we will have the security credentials. And here we can do something called create access key, right? So I click on create access key, and right, in a local development environment to access your application account, there's the use case, right? And click on next, confirm, I read all this. Okay, so give it any name, again, TF access key, right? TF AWS access key, something like this.
Is there a specific purpose it asks that thing, or
which one?
like in the step one, it asked,
What's
what
the
is
use
the
case?
purpose of,
Yeah, what's the use
Yeah,
case
okay,
which you're
okay.
trying to do? Hmm.
No, I think they're just trying to capture that information to see, like,
Okay,
yeah, just for auditing it. Yeah, and
got
further
it.
analytics. Yeah. So access key ID I have given, and now access this as well. I have to copy, and yeah, yeah. I can't ask you all of you to close your eyes. Well, stop sharing and run this quickly. Right, so I have done that, and let me share screen. Okay, so yeah, so the access key, I mean, the configuration has been done, and it will be there in that. And from AWS, if we go to see this and refresh as well, I think, yeah, so it will say connected with this particular profile, right? TF access key or whatever, it will show up there after we do AWS config. So let's actually run this, right? So we'll do Terraform plan that will try to say invalid block. What is wrong here?
Line number 2 at the end, it is showing that mark.
Yeah, it's always with that. Yeah, whenever we copy paste from slides, it's double quotes.
Double quotes look okay though.
Yeah, then I think something else
I
is
think you have to
wrong.
just press, you have to have that open braces over there. It was the same error for me.
Oh,
Yeah.
really? Okay. Okay, yeah, got it. Thanks for that. So let's do plan. So now, as part of plan, it will actually connect to AWS using that provider, right? And credentials that we have provided, and then figure out, oh, does this already exist, right? That's the question it checks, right? Like, does this already exist in the real world? This is desired state from the user. What is the actual state it will try to get, and then try to generate this diff, right? So that it can take the necessary action, right? Let's say, I mean, I'll run this again and show, so that time it will say I'll not attempt to create because it's already there, right? So first time this being done, so it will obviously it will not find this in the AWS, and so it will attempt to create. Okay, it's taking time.
Sir, any specific roles needed for attaching to the user to enable Terraform to create resources?
Yeah, good question. So yeah, I think yeah, that way it'll again fail. Yeah. So for this TF AWS users, uh, so permissions or authorization, anything that we want to give, like it should be able to do this, it should be able to do that. In AWS, in IAM, the concept is policies. So it should have those policies to be able to create them, right? So for this user, we have to attach those policies in the form of here, right? So under permissions, we say add permission, and then we can attach policy directly. I'm not having any groups and all. This specific user I want to attach, DF AWS user, right? So I go here and then say AWS EC2. There is something called, I think, read access, write access, and then you have full access. So maybe let's give it full access, right? So that way, everything related to EC2, it should be able to do. So I'm giving this particular permission here, right? And for example, for buckets or S3, based on what all entities or resources we want our Terraform user to have access, those only we try to give here, right? And that way it will not accidentally do something else that is unintended, right? So it's all, I think this is one of the best practices as well, like minimal access, right? And give access to only those that are absolutely needed. Okay, so let's see this. Okay, so the plan it has come up with, right? So it has completed this, and it says whenever you see a plus, it is like it's attempting to create, right? So plus stands for create, minus stands for destroy or delete, right? And tilde
Sorry to
icon
interrupt.
stands for,
Sorry to interrupt. One
yeah,
question here.
yeah.
Uh, Earlier we were not having role and we started off with Terraform plan step. Now that wouldn't allow EC2 instances to be read. So this command should have failed earlier, right? But just
No, no,
because we
this
kind of
is
added role in time, it managed to.
no, no, this is just planning. So planning is fine. The execution would have failed. Yeah,
Execution would have failed.
yeah, yeah. The
But
apply part.
even for plan phase, it is going to see whether I have that resource or not, right?
Yeah, you're correct. So read-only privilege, yeah, maybe was it like, yeah, I should have deleted this and rerun.
No,
Now,
no,
yeah,
that's okay.
yeah,
That's okay.
yeah,
I'm just checking. As in,
yeah.
even for generating the plan, it will
Mhm.
need to see if that resource is there
Correct.
or not, and then
Actually
only it
exists.
will
Yeah,
say, right?
yeah, yes, that is
Okay.
correct.
Okay. Thanks.
So yeah, here it is planning to create this. It is saying it will be created this particular resource. It is plus, minus for destroy, and tilde for any changes, right? Tomorrow, let's say rename this, change the name, I can do that. So resource ID will be the same. Here name I can change, right? What I see, it's just a key value pair, right? So then it will be showing as a modification or some other configuration I add further. Those are all modifications. So I'll proceed with apply here. Right? And even as part of apply, it will again generate this plan and then ask our confirmation, wherein we have to type yes to say yes, I mean, go ahead. If you want to avoid that, giving that again, the yes part, you can say Terraform apply and then hyphen hyphen auto approve. So if you run that command, it will straight away uh, take that as yes, right? So Terraform plan we have seen, Terraform apply we have seen. If you want to auto approve, it is hyphen hyphen auto approve. If you run with this, you don't have to type yes in command line again, right? It doesn't wait for anything, it will proceed further. Okay, so now I'm expecting it will, I mean, prompt me to type yes or no to confirm. That confirmation we can skip by auto approving here while running this command. And usually in Jenkins or any CI/CD pipeline, you may want to have it like this because you don't expect anyone to. I mean, there is no input. There is no one to give that input whenever it is asking for. Yeah, this still slow. So I mean, while we wait for this, let's cover a few more slides. So here in this particular slide, again, I'm picking up a use case where you can deploy your backend application like the main.py. I mean, Python application you were doing as part of assignment as well, right? So you have to push your Docker image earlier. I think you are pushing it to Docker Hub as a public image if you wanted to access, create it in Docker and access it from somewhere else. But here within AWS stack, you have to push it to ECR, which is Elastic Container Registry. Difference is Docker Hub is, I mean, public and open source one. This ECR is proprietary, owned by AWS, and private one, right? So this way your images are not accessible to others. Only via IAM proper user authentication they'll be able to see these images. So you push that Docker image, create a main.tf, add the AWS provider, AWS ECS cluster resource. You can define ECS task and then do Terraform apply, Terraform destroy. Destroy is just to get rid of all the resources, right? So I have added all the necessary code in slide, so I will highly encourage all of you to go through this, right? I mean, we are doing one thing end to end very clearly, so I'm hoping all these similar ones. It's just yet another resource and yet another cloud, right? It should be the same.
Main.tf is it
yeah.
utilizing the provider, right? So
I'm typing yes here quickly. Yes, Gautam. Please go on.
main.tf is
Yeah,
in
I
turn
mean,
using
it could have
providers.
been. Yes. So yeah, the way it is using is because of this. In resource, if you recall, the syntax was provider underscore the resource type. So here this AWS is defined here.
Okay, okay, got it.
Yeah. So just go back to this syntax, right? So provider, we create like this, right? We say AWS equal to and this variable we create. And in resource, the syntax is the provider underscore resource type and then resource name. Resource type is instance for EC2. It will be uh, object store, I think, for S3 and so on, right? So it will have different names. Yeah. So for example, here AWS instance is that EC2 instance. And here S3 bucket is the resource type for creating S3, right? But provider is AWS again, right? So hoping this is clear. Okay, Gautam, can you please confirm?
Yeah, still clear. I have one doubt.
Okay.
I mean, not
Yeah.
sure I made it or not. So
Yeah, just give me a minute and I'll take your
yeah,
down.
sure. I'll
So
go.
it's creating and then it says creation has completed after 13 seconds, right? So let's go back to the AWS here and open. So one thing is if you frequently keep visiting these, they will come up under recently visited, or you can also pin them wherein you can add them to your favorites so that they'll list under here. Okay. So now we should see two instances. And if I go to the instance, you see that you have this. Okay. Why is it very small? Let me reduce this. Please. Okay, so you have SSD TFVM, right? Okay, let me click it again. Yeah, so you see both, right? SSD GUI VM and SSD TF VM. This is also getting created and this is also accessible, right? All the checks pass, same T2.micro and everything. The change is we did it from script, right? So now infrastructure is written in code, I mean infrastructure as code, and then using that you were able to create same thing that you would have done using UI, right? But this is scalable and repeatable, right? Like the same thing I can do it in 100 accounts, right? For 100 customers, right? And it's repeatable, consistent, and same and configurable. I'm hoping this is clear, right? Does this make sense? Please confirm everyone. So now what will happen? These are the questions you have to think about now, right? So what will happen if I do Terraform apply? And this time I will do this auto approve, right? So that it doesn't even ask me and forcefully, I mean, I'm asking it, do this again, right? But will it create another instance? The answer is no, right? Because of idempotency, because we say we desire this particular, and yeah, the name you would have seen, SSDTF VM is the one that got created, right? Not the one we give here. right? This name is specific to Terraform. This name is the one that is being created in AWS. Okay. And how do you, I mean, why do we need this, or where do we make use of this is, let's say this resource you wanted to use somewhere else downstream, right? So that use case, again, I have it in the object store, I mean, in the multi-cloud setup, I think. So I'll show you this use case. Or, I mean, maybe I can just create a VPC here and quickly show you virtual private cloud. My point is, like, let's say you wanted this particular resource and you wanted to create another resource that depends on this resource or uses some information from this resource. So the way that you try to create, right? Yeah, so Google Compute resource, if you wanted to create, you can give it this name, right? And right, so yeah, so instead of these, let's say the machine type, I mean it's E2 micro here and not T2 micro, but maybe this name, right? I don't want to repeat it again and again. Maybe this, I mean, it's not a good example, but I'm just showing you. So I could have derived this using AWS instance dot uh, this SSD within TF VM, right? This not this name. It's basically called fully qualified name. So you do this dot and then tags of name, right? So tags of name has this value, right? So that is the name I'm giving here, and that's the use case of having this, right? So basically, I mean, even before certain resources are created, for example, this resource, every resource will have an ID, right? Instead of tags, maybe ID is a good example. And if I use dot ID, this ID is not even there, right? Because it didn't even create, right? But once it gets created, it will get at that ID, and that ID it will use here, right? So that way these things are useful. The names within Terraform. I think someone asked this earlier, just showing this. So now if you see, Terraform has compared your real infrastructure against your configuration and found no differences. This is exactly what I said, right? Like actual state and desired state. It compares, it found no changes. So it says apply is complete, resources added are 0, changed are 0, destroyed are 0, because it sees that it already exists. So this is that idempotency, right? Again and again, you run this script also, it will not create so many VMs. It will just create how many ever you specified here, right? So there is no harm in running this multiple times, right? Terraform apply. Hoping this is clear. Please confirm.
Sir, I had a quick question here.
Yeah.
Like I accidentally tried to create the virtual machine with the same name as in Terraform, and I later changed it, and it applied the change. The question that I had was, I also had other virtual machine that I directly created on the AWS console. So
Correct.
now, how did
Yeah.
it identify that it has to exactly change the name of the virtual machine that it
Yeah.
created, and not the one that was already earlier? Like,
Correct. Yeah. Yeah. Yeah, good question. And actually, that was the one I wanted to cover next, which is called Terraform State. So Terraform State is the answer, one line answer for you right away. So Terraform maintains something called a state, which is basically all the things that it created, it will keep track here. It's like the scope or view of AWS. So AWS in its entirety is not its world view. Its view of AWS is stored here in the form of Terraform state. Right, so here it will, for example, here it has stored this AMI ID that I selected and the name, right? AWS instance and all of this, the name here. So this is the one that it will query AWS to find, right? It has only one here because I declared only one here, right? So using the Terraform state is the answer, but we'll get to that, right? I'll quickly complete this multi-cloud ISE and come there. So multi-cloud IAC wise, I mean, in this example, okay, maybe let me make this full screen. We just have 9 more minutes, but I'll try to cover at least the IAC in its entirety, if not the security part. So let me finish this.
It's okay if you overrun for some time.
Okay.
We have taken good amount of time for queries today.
Okay. Okay.
So,
Yeah. Thank you very much. Yeah. All right. So, yeah. So here the example is multi-cloud IAC example wise. We want to set up a Lambda function, which is serverless Lambda function, right? Lambda function is you declare, for example, very simple explanation for this is if you want to define a function called add that takes two numbers a comma b and returns a plus b, that function, if you keep it running on a EC2 instance, every hourly you have to pay AWS, right? Because even if someone uses that function or not, because you are deployed that function on EC2 instance, which will be charged hourly basis, you will end up paying to them. Whereas serverless concept of this Lambda function is um, it will only spin up whenever someone actually calls add 2 comma 3 or so, right? So that way you will be charged only for the usage, like actually when someone is using the add function, rather than just keeping it up and running every time, all the time, right? So that's the quick difference between server and serverless, and Lambda function, in short. Hoping that makes sense, right? Like, let's say in a year, maybe this IT returns thing, that's a very good example. Like clear tags or any other portal that you use, you hardly use only in the month of that June, May, or whatever is the deadline, that 1 month in a year, right? You never come back to that throughout the year, right? Very less frequent, right? So as part of that, they can actually run those services on a serverless machine instance rather than a server one, because if it is a fixed server like EC2 instance, they have to pay it hourly whether or not people use it or not, right? So that way this is there. And the example here is serverless Lambda function we want to create on GCP. We want to create a VM on Azure, and we want to integrate these two. Like we want to call that Lambda function from Azure, right? So from Azure's VM, we will write a script inside this, which will call this Lambda function. Okay. So, how do we test this now is, basically in the slides, I'm trying to give various flavors so that you get to know, or you have the syntax exactly for how to write a provider for AWS, how to write a resource for AWS, be it ECS cluster, be it bucket, be it server, EC2 instance, and so on. I'm just trying to give all types varieties here so that you have like that handy, right? So for example, here we have like, we want to set up the serverless Lambda function on GCP. So we need provider first, which is Google, right? We can give it any project it expects and region. And then we are writing our main.py file, which will be the function, right? Here we are again having that greet function like how we did for main.py, right? From Fast API, this is a Fast API based application. We could have used Flask as well, the same code that we had earlier. Only thing that is getting added here is Mangum, which basically makes it ASGI compatible. Generally it is asynchronous function in Fast API, and you want it to be, synchronous here. I'll not get into too many details here in the interest of time, but you're just wrapping that app in this and exposing this handler. These are the requirements.txt if you wanted to try. Only thing is this will get added. Here you had Flask instead of Fast API, right? So, which is still the same. Now in GCP, we are again creating a bucket, right, to object store with this particular name, because we want to upload that source code, right? That source code main.py, whatever we wrote, we should be having it in GCP accessible. So we will create a source zip file for it, source.zip name, right? And we will upload our main.py code to this. Right. So main.py and requirements.txt, we will create a source.zip file. That zip we will upload to this, right? Like how you created your assignment zip when you uploaded. We are doing the same, and we'll upload this to this bucket, right? So that is why we are creating a bucket and object inside the bucket. Okay. So these two thing is clear. And then step 4 is the actual function, the Lambda function from GCP. So it is cloud functions underscore function. Here again, all places I'm giving that SSD as just a unique prefix. You can use your name or initials of your name. And GCP Lambda function is the one that we are using. So runtime, we are declaring we need Python, right? Because the code we wrote, the main.py is in Python. Entry point, we give all of this, like trigger HTTP we are exposing. So after you do this, what you get, for example, is a public HTTPS endpoint. It will look like HTTPS region-project ID in Google. That is why in provider configuration, we had to give both of these, right? If you see here, we had project as project ID, region as US East 1. So in that case, the URL will come up something like this. It will be the region US East 1 hyphen project ID dot cloud functions dot net slash this cloud function name will be here. Right? So the same name you'll get here. This is a URL that you can even locally test from, laptop using curl command as well. You can call this function, but we want to do that from Azure VM, right? So that is where we are again using provider from Azure. For Azure, it's Azure RM. Resource manager, I think RM stands for, and create the VM here. So you are creating a virtual machine, right? Remember the name is virtual machine there, the type, resource type. You give it some name and these credentials, you can give it here or you can, in this example, we are just giving it here. And once you have this, we are also creating a invoker.sh, the shell that will call this. All we are doing is the same, right? Like curl -get and this URL. Right? And you should be able to run this. We are making it as part of init script so that as soon as the VM is created in Azure, immediately it will run this invoker.sh and internally it will call this Lambda function. This is how we are integrating a VM in Azure with the cloud function, Lambda function in GCP, and both of these are integrated, right? So this is just to showcase the power and multi-cloud IAC as a concept with specific code. And yeah, we can't, I can't try this out and show you as a demo because we don't have access to both these cloud, environments. But if you do have like free access or so from your org and or so, you can give it this a shot, or within AWS itself, you can play around with these, right? Like creating one bucket, one server, and so on. So to quickly summarize the difference between, please confirm if multi-cloud IAC is clear, like how we can keep mixing all of these, and from Terraform, it will just look like yet another provider, yet another resource, right? That's all. We don't have to really worry about what cloud service provider it is. We just declare it as one of those providers and then create a resource. Okay. So Terraform versus Ansible versus Helm. Terraform, as we have discussed in detail now, you know that it is to provision and manage the cloud infrastructure, and you're declaring it as code. For example, if I ask you how do you spin up a load balancer, a VPC, a Google Kubernetes environment, and so on, right? EKS, Elastic Cloud Kubernetes service from AWS, all of that infra, if you were to set up, you would write the code in Terraform using Terraform, right? Or one of the IAC tools. Ansible, on the other hand, is called CAC. CAC stands for Configuration as Code. So what Ansible tries to help you is, for example, once the infrastructure is set up, you want to install Docker, right? You want to install kubeadmin, you want to install Helm, right? All of these you want to run, right? So that you can do so using Ansible. Right. So in real world, they coexist. It's not like one thing is better than other. They are all coexisting and they're solving different use cases that I'm explaining here. Right. And finally, why do we need Helm? As you know, Helm, all our application. What is Helm in short? The first use case we discussed was it is a package manager for all the Kubernetes objects we have for our application. Right. So all the YAMLs that we have for our app, Helm will package them in the form of a chart that we can have it in some remote artifactory location. And then we can use Helm to install that chart, right? Which will apply all our Kubernetes YAMLs, which are nothing but deployment services and other things for our application. So Helm, using Helm, you can do that. But Helm itself we need, right? So that will be solved by Ansible by installing Helm, installing Docker and others. And even before this, we need some infra, right? Like you need a server where you install Helm, and then using Helm, you can install our apps, right? So that's where these three are linked and they coexist. Hoping this is clear.
Yeah, this was very good, sir. Getting that context and they coexist as in they are helping different use cases is the right
Correct.
perspective to look at them.
Yes. Yeah. Else it will look like a chicken and egg problem because for installing our application, we need Helm, but for installing Helm, we need something else, right? So it will never get solved like with Helm itself. It's like sitting on its own branch. So it won't help. So that's why we need other tools to set it up. And for example, even for Terraform, it is the same. For example, that user that we created, the Terraform user, we say we are automating all the things. We don't have to do anything manually, but the user setup we did first is needed, because then only Terraform can talk to AWS or other things, right? So those we still have as part of scripts, which we have it in pipeline or CI/CD, or sometimes they are just one-time activities, so we do it manually. But the thing is, it's taking care of the larger things, like the larger use cases of the entire application related infra. It's able to declare and manage for us. So those are some of these. Yeah.
True, true. And this also gives us a perspective that what we need to learn, as in there are a number of tools in the market. We need to at least understand single flow properly.
Correct, correct. Yes.
As soon as we do that, we are like good enough to kind of deal with situation across
Correct.
other tools.
Yes.
So this kind of gives
Okay.
us that clarity.
Yes. Agree. Yeah, someone else had some question.
CSC
So I
full
think,
form.
yeah, yes, Gautam.
Last screen. CSC, what is the full form?
Configuration as code.
Okay.
So IAC is infrastructure as code and CSC is configuration as code. We also have something called SAC, which is security as code. And we have another CSC, which is compliance as code. So those two as well, I wanted to discuss today, but yeah, security part maybe in the last class we'll cover. Um, so yeah, coming to the state and
Ansible we
locking.
have not seen, right? Ansible we
Correct,
have not
correct.
seen till now,
Yes,
right?
yes,
Okay.
yes, yeah.
Okay.
So coming to Terraform state and locking, like why do we need a state is without that state file, Terraform doesn't know like what's already deployed or what is it that Terraform was managing, right? Like that information Terraform only knows like this, because for example, the manually created VM, SSD GUI VM, Terraform will not kill it, will not touch it, right? It will only touch the SSD TF VM, and how does Terraform know about it is via its state. So state file, which is terraform.tf state, generally state can be managed locally, or there is something called a remote backend we can configure, wherein this state file will be pushed to that particular remote backend, right? And it is suggested in an organization when you are collaborating as a team, you want to have all the state remotely, not locally, because whatever you have locally, it may be conflicting with some other developer which they have locally, right? Like you both parallelly like try to maintain the same state, it will be confusing, right? And it may result in errors as well, like when both of you with the same name try to create some resource or so. So we always want the state to be remotely saved, and some of the options we have, we can use an AWS bucket to push this state to remote. So quickly that part I'll show here, right? So we say it's uh, we start with something called backend, right? And then we can say it's remote, right? And then we want to say like we want to give the details of that S3 bucket or so.
Is that if we have multiple Terraform scripts, in that case,
Hmm.
it should maintain a separate states, right, for each Terraform script?
Um, yeah, so yeah, I'll get to that. So even if we had like 100 Terraform files here, all of them will maintain in the same state, right? Like Terraform is like unified across all. So
Okay.
the state information it will maintain is it will parse something like star.tf, right? All the files that have TF extension, it will parse, because the split that we are doing here is purely just to modularize the thing, like how we write source code also, wherein for example utility common functions we write in one file like shared.py, and then in main.py we call them and make use of them and so on, right? So it's just for organizing this better. That's the reason I called this providers, so that we have all providers here, and main was the one where I have that application code. In general, this main is also further split into what we actually create and manage, and so on, right? So there are like various project hierarchy and best standards people follow to have this, but Terraform as a whole maintains that state, which we want to have it as a shared state, because infrastructure itself is shared, right, in the first place, because organization expects the same amount of resources to be shared by all the people in the org. So we
Correct.
have to push this to the remote backend, and there are like some options. I think I have one in slide that shows this. So backend, we say like inside Terraform, we say backend and then S3, and we can give the bucket name, so that when we do this, it will push that state file to the remote, right? So it will no longer create it locally. So this one, it will not create, it will create it remotely in the S3 location. Okay. All
Yeah,
right.
with
So
that,
now, yeah,
with that,
sorry.
every user who executes that command,
Hmm.
for
It will
him, the remote file becomes the source of truth
source of truth. Yes. So that way it's consistent, so that two
across all.
users, yeah,
Mm.
accidentally don't end up managing or
Step
creating.
on each other's feet.
Correct.
Mm.
Correct. Yes.
Got you.
Because
Got you.
infra itself was shared, this is also being shared now by pushing it to remote. And second thing is, what happens if uh, two users try to run, even though if it is remote, right? Right, like they will check out that remote file, and now two users, let's say they run Terraform apply, right, from their VMs, from their laptops in parallel, right? It will attempt to create the same resource. This is called that race condition in OS, like two
Correct.
processes
Correct.
sharing same code, I mean, modifying the same code or accessing shared resource. Same thing will happen here as well, right? So to solve that is where Terraform has the mechanism called locking mechanism.
Locking.
Earlier they had DynamoDB integration. Now I think natively Terraform is supporting this locking mechanism as well. So in DynamoDB in AWS, the way it will be created is the table name is generally Terraform locks, and the primary key is on the lock ID. And whenever a particular user, let's say I am running something, so it will capture like who, which is Sushant that read this laptop, and it will have some ID, right? Like maybe the tf state file will have this ID. Like if you had terraform.tf state in prod folder, right? So I think that part I missed out. So you can organize these TF states. I mean, basically have different TF states for different types of environments, like prod, dev, like this, right? So this point. So you can use like dev staging, dev slash TF dot state, prod slash TF dot state, because uh, what you want to essentially have state for is for a given application, all of its tech stack, be it server, database, etc. But different environments, maybe you want to isolate, right? So that dev wise you take care of, I mean, have it in one TF state,
Agreed.
prod
Agreed.
wise
Yep.
you have.
Mm, mm,
So that will become the ID here, and it will
mm.
say that is being locked, right? That is the primary key, so that when I am doing something on prod, unless I release this lock, it's like lock and release mechanism. There will be a lock applied when my Terraform apply is running, I mean, whatever I triggered, and it will have a timestamp, so that first come first serve basis. So I started it. So someone else, when they run, it will say resource busy, like, I mean, it's logged, right? So they can only do it maybe in dev or other tiers, I mean, other environments, but not in prod till I finish this. So that way it will avoid race condition, because even if both are trying to create the same resource, mine will actually create the resource. The second person's execution will just see that it already exists and skips. Right. So that way,
Correct.
the
But
resources.
sir,
Yeah.
is there a problem? I mean, say 2% really running the same IAC code via
Correct.
Terraform. So
Yeah. At the
even
same
though
time is
they
the problem. Yeah. At the same time is the problem, because for both of them, the actual state would have been no server exists. So for both of them, the plan will say I will create a VM with the same name. Right.
Correct.
okay
So
name
both.
conflict.
It's
Okay.
So
exactly
it's
similar
a
to a
race condition. Yeah. Yeah. Yeah.
shared variable being updated by two different processes, right?
Yeah, it's like
So until
creating
that,
create table statement in SQL. If you're familiar with, you say create table T1, you have a SQL that is there in version control system. You also check out, some other person also checks out parallelly at same time you're hitting that.
Why
So
the name tag will conflict? Say I need six
yeah,
VM now. I mean 6 EC2 instance. So I have this Terraform script ready. Six
yeah.
time if I run, it should create six EC2 instance form. Now,
No, it doesn't.
does it matter if I run parallelly or
No, no,
one
no,
by
no.
one?
No, that's what I try to explain. If I run this 100 times also, it will still create only one VM with this name. If you wanted
Okay.
six, you have to
Mhm.
copy paste these 6 times and give different names. Right? If you wanted six
Tag should
VMs,
okay.
yeah,
Mhm.
they
So
because they
name
all
kind
are
of ID
different.
here in unique ID.
Correct. Yeah, the ID
Name.
should change. Else, yeah, even if I paste this 6 times and I generate plan, it will still say it will create only one because
Okay.
yeah. So it's the same.
So we can programmatically do it like you were showing earlier, right? Where @ID, which would, because the ID would be unique
Correct, like
every
this.
single time.
Correct. Like yeah, we can access the ID. No, my point was yeah, I think compilation itself will fail. Like it say it was already declared, right? So it has to
Okay.
be unique.
Let's say like the requirement is to have one dev config and one test Terraform template. So in that case, even though the environment is same, so will it allow in that case, or in that case also it is like the Terraform state is unique to unique to the environment and not to the script?
Okay. So
Sir, one question I have, suppose this Terraform state file is corrupted or lost, do we have any way to reverse engineering to regenerate that like that?
yeah, so usually we, I mean, configure it to be in the remote backend, and Amazon has like that 5 nines or availability, right? 99.999% available. So it's very rare case that you lose that info if it's a remote backend. If it is local TF state, you may lose it. But again, the TF state, actually the beauty of it, I'll show you. So even if I, let's say, delete this, right? I mean, these are the things you have to know, think about, right? Like what will happen if I run Terraform apply now,
Yes.
right? So it will, yeah, me,
It will first build the plan and it knows
yeah.
what
So
it.
I think this backend I unnecessarily configured. Let me remove this part. Because it's, I mean, configured some S3 bucket,
From
it was looking for
instance,
that. Yeah.
we never identify this is created through Terraform like that. We cannot identify, right, sir?
So this TF state is basically its local cached representation of how the real world looks like, and also what are all the objects that Terraform has created. That's the information it tries to have here, so that instead of looking at every resource in AWS, it will only look for these resources. It's like used for filtering, right? So that it quickly can check whether these things exist or not. But let's say this Terraform TF state I have deleted itself, you can see that it will create it again, right? So because it will always get that real world representation, and that way it will be able to fetch what is existing currently, the real world representation of it. And I actually have a few scenarios. I'll quickly cover that. That way it will become more clear. Let me just finish this serverless thing. We're actually out of time. Just 2 more minutes and I'll wrap up. Okay, so just to showcase like AWS cloud formation wise, how does it look like? From AWS, we have something called SAM, which is serverless application model, right? SAM stands for serverless application model. And here is how that it's a YAML file format, and you say AWS template version, serverless, my lambda function, AWS serverless function, and so on. Right? So this is similar in one sense to the GCP function we wrote earlier, where we said runtime is Python and all. Right, so this also gives you this, but here you see you don't use Terraform build, you'll say SAM build, right? So which means for each cloud native IAC tool, you need its own tech build tools, right? Whereas Terraform is making it generic. I actually have a article if you're interested to set up this entire thing. Uh, so you have it attached here, right? So if you want to follow along, like where create a AWS Terraform backend, which is an S3 bucket, create a DynamoDB table, create a repo for AWS. I mean, have a code repo not in Git, or I mean not in GitHub, but in AWS as code commit. This pure AWS stack you're following, and do this particular tech stack if you wanted to set up like dev and stage. This is a very good article. So I have this link. You can follow along to practice, right? Because you always, I mean, you already have AWS account free from Bits, so you should be able to follow along and create all of this end to end to explore further. Okay,
Is this
so
similar to the use case that I was telling?
Oh, okay. Is it? Okay.
Like the having a test and dev environment and different Terraform scripts for each of them. And is this something similar to that? Or?
Yes, yes. I think, yeah, here it is stage and dev or stage and prod something. Yeah, in this diagram. Yeah. So it'll showcase, yeah, dev and stage, how you can isolate and create them. So yeah, this article helps to do that. So it's just like you have a different folder and TF state. So whenever you're running Terraform, apply, you specify that path, right, to the TF state. So it will accordingly change between prod and dev. Okay. So yeah, I think, yeah, most of.
Is it a practice to keep that .rf file as part of, yeah, the one which gets created when we run this command? Sorry, I think you deleted that file. Do we put that in source code, as in do we version control it effectively?
Which one? The TF state file?
TF state file, correct.
No, TF state we discussed, right? We'll have that remote backend. It will be there in AWS S3 bucket.
Correct, correct. That way we will have latest copy of that file always. But if something goes wrong, let's say I do something today, that change will get replicated. I won't get a
In
file which was
S3
there.
S3 bucket, we enable something called versioning. There is versioning feature from S3 also.
Okay.
Yeah, yeah.
Okay, got you. Then fine. Yes.
Yes. Yeah, so I think mostly this is what I have with respect to ISA. So like couple of questions to think about, right? Like maybe let me say this food for thought, and you can probably think about these and find the answers as well, right? Is let's say I mean, I manually go and delete this, right? Or you should also do this. I thought I'll showcase this. I go manually and delete this, right? I know Terraform is managing it, but I mean, I don't care, right? I just go and delete it. What happens, right? When you run the Terraform apply next time, right? So will it identify this diff? The answer, you should get it, right? By now, from all the theory we discussed, you should be able to answer this question, which is, I mean, will it error out or will it do something about it and so on, right? So think about those corner scenarios.
Sir, this final document where you uploaded for to print.
Yeah, I'll upload this code under IAC demo for today's lecture. Yeah.
We don't need to wait for next session, right? Or we, right?
Today itself, yeah, I'll upload, but 16th session, no, the final PDF PPT you're referring to for printing.
Yeah, for printing.
For printing, I would request that you hold on till 16th session, like the Sunday. Actually, I have one request. Can we schedule this session on Saturday instead of Sunday, like same time? Is that okay with all of you? I'll actually make a announcement, but wanted confirmation, right? Like Saturday, the same time would work for all of you. Just to finish off this early. Okay. So
Sir, I think there is other subject, API-driven cloud native solutions is at the same time, but any other time works for me.
Okay.
Saturday,
Thank you.
I have also session.
Okay, 3 to 5, is it fine? Like 3:15 to 5:15 or something instead of 5:50?
Yeah, that works because 5:50 to 7:50 is the API-driven solution.
Okay.
I have 3:50 secure fundamental. We have.
Okay. Okay, so maybe 1 to 3, is it fine then? 1:15 to 3:50.
When's
what? On
Saturday.
1 o'clock. No,
on Saturday, sir. Yep,
Okay.
that works.
Okay.
We have
I'll
class
schedule.
We have 2 classes.
Yeah,
one
I'll
in
anyways check
morning,
with the team
other
to
one
check your schedule and only let me know the free slots. But I'm just giving heads up that we'll try to have it on Saturday instead of Sunday. And Saturday night I'll upload that consolidated PDFs for you to take a print out. Yeah.
So can you upload this one, the one we had today? I think the practical part I kind of left behind. I wanted to do it.
Like how we have been doing so far, every day, I mean, every session that PDF or so, individual one I'll upload right away. I was talking just about the consolidated one, right? Which
Okay. All right.
Yeah. All right then. Yeah. Thank you everyone for staying back and
Thank you.
Thank you.
Sir, just a second. I have one question regarding
Sir,
assignment part.
from assignment standpoint.
Yes. I'll stay back. Yeah. Whoever have questions, please.
Sure.
Hello.
Yes. Yes, Pradeep.
I'll
Gautam. Yeah. You can go.
Sir, am I audible?
Yes, Himabildu. Yes. I mean, yeah, multiple people are
Sir,
speaking. Maybe Gautam can go first. Just
okay.
Yes, sir. Yeah. Want to share, sir. Okay. I can read out also.
Okay.
So the task 4, it is asked to